Here we go. So we're going to learn how to graph sine and cosine graphs, changing amplitude and period length. So we've been dealing with the unit circle for a while. Now we're going to change amplitude and period length. So to graph these things, we're going to make them very basic. We're going to make a little graph like that. There's my x and my y table here. We're graphing 2 sine of 2 theta. So the thing we're going to look at first is the number in front. The number in front is going to tell you the amplitude. Okay, so this 2 right here is my amplitude. That's how high my graph is going to be stretched. So in this case, since it's 2, I'm going to make a graph over here. I'm going to go up to 2, and I'm going to go down to negative 2. That's where my graph is going to go. So it's going to live in between those two worlds. So I like to draw like a line here just to show that's as high as I go, that's as low as I go. The other thing is that it's 2 theta. When we're talking about a unit circle, how many radians do we have if we go all the way around a unit circle? How much is that? Well, just look right here. If I go from 0 and I go all the way around, it's 2 pi. It's 2 pi. So to figure out the period length of our graph, and that means how long does it take for the sine curve to repeat? Okay, you're going to take the number in front of your theta, and you're going to multiply by the reciprocal. So you're going to take 2 pi times the reciprocal of 2. What's the reciprocal of 2 going to give me? 1/2. Okay, so that means that my period length, 2 pi times 1/2 would get me pi. That right there is going to be my period length. Okay, and it'll make sense here in a second. So if I'm doing period length here, that means on my x-axis here, I'm going to mark 4 lines every time. 1, 2, 3, 4. Whatever your period length is, that's what you're going to label this last one. So this one right here is pi. So if that one's pi, the one in the middle is going to be what? Pi over 2. And if I cut pi over 2 in half, what's this one going to be? Pi over 4. So if this one's pi over 4, pi over 2, what's that one going to be? Think about it. This is 1/4. This is 2/4. So it's 3 pi over 4. Okay? Sine curves are really easy to graph. Okay, you just have to know where to start. Look at 0 radians on my unit circle. At 0 radians on my unit circle, I'm doing sine. Sine means y. So what would be my sine at 0? It would be 0. So at 0 here, I'm going to make a point at 0. Theta just means how many radians it's in. Okay? And then it's really easy. Every jump in between, you're going to move to the one, either up or down, one spot. Okay? So I could be here, here, or here. So the top line, the middle line, or the bottom line. So since I start in the middle, and we'll talk about this again through the notes, but this is just a little bit more in depth here. At pi over 4, I'm going to go up to the line. At pi over 2, my only option is I can only make one jump. I can't jump to the bottom. So at pi over 2, I'm going to go back to the line. At 3 pi over 4, I'm going to go down. At pi, I'm going to go there. So sine curves start in the middle, and then they go up. And then you just go up 1, and then keep going back and forth in between. Here is my sine curve. I'm done. Okay? We'll make more sense of it as we go, but there's the basis.